which questions do you have? We are gonna, this is not section anything, is it? What is this, practice test?
Test review.
We'll call it practice test. Chapter 3?
Yeah.
Alright. Alright, so what do you got?
16.
16?
Yeah.
Okay. What else? What about
21.
19 and 20.
21, please.
Not 19. You meant 20 or 21, right?
I said 20.
We'll do
Oh,
21.
we're doing the. Oh.
Practice
I
test.
thought we were going over. Okay.
No, yeah, I'm not going over the numbers that are on the test. I'm going over that homework.
Yeah,
I'm going over the homework problems.
But I thought you were gonna like.
But these
do
are like,
examples.
they are.
Oh, okay.
16 is like one on the test, and
Yeah.
21 is like one on the test. So, all right, you want to just do those first, and then if you have anything else, we'll do that because these
Yeah.
are long ones anyway. So let's do 16. So let's find the distance between the parallel lines. So y equals x minus 11, and y equals x minus 7.
Okay.
All right, this is on 227. Oh, you know what? You probably can't hear me very well. It's gonna be all bouncy and messy. Because I have my, this is what I use when I record, and it sounds much better than when I use the mic from the. Yeah, it will be. It'll be all muffled and ugly sounding, but now it should sound just beautiful with my my soothing voice. I talked to a couple parents yesterday, and they said, I talked to one parent, and she had never met me or seen me, but she had heard my voice on the videos because her daughter, I guess, was watching the videos. She says, yeah, that is your voice, or that is you, or something, because that's, that's kind of funny that she had only heard my voice. And I apologized. I said, I'm sorry that you have to hear me all the time. But I said, I tell the kids put headphones on so you don't have to hear it. She says, no, I was actually learning a lot.
You don't tell us to do that. I do it for you.
Oh, is that right?
I actually know how to do this. I actually remember this stuff. It's
Good.
so easy.
All right, let's do this thing right here. Let's graph it. It doesn't have to be super accurate, does it? So I'll just say down here is negative 11, and so we'll put a y-intercept right here, and the slope is 1, so rise 1, run 1, we'll put it about right there. And might not be perfectly to scale, but it doesn't really have to be. It's just to give us a guideline. Oopsie daisy.
Wow.
I know, I missed it. There we go. All right, yeah, it's just to kind of give us a visual idea of what's going on. All right, and let's go green. All right, so that's, and then negative 7. Negative 7 is probably a little closer down here, but let's stretch it out just a little bit. Is that all right? Just to give us a little room to work with. And the slope of that is also 1, so it's the same exact slope. You know what I'll do? Since it's parallel, just to make this a little more accurate, I'll just copy and paste it and put it right there. So then now I know it has the same slope, and I'll make it green. See, wasn't that smart? So they have the same slope, and that's at negative 7. And what are we trying to do? We are trying to find the distance between those two lines. So let's go through this quickly as I can anyway. You could start from the negative 7, drop it down to the orange one, or you could start from this negative 11 and drop it up to the green one. Doesn't really matter. Which, do you have a preference? What's that?
Wouldn't you pull it up, not drop it?
Doesn't make any difference. You could go from here to here as long as it's what?
Perpendicular.
As long as it's perpendicular, okay? As long as it's perpendicular to this, it's perfectly fine.
Y-intercept.
I did do the
yeah,
y-intercept.
that one.
It doesn't really matter. I don't think one way is any easier than the other, to tell you the truth. I just decided to go from here to here. No special reason, okay? So what are we trying to do then? We're trying to find this point, aren't we? So that's the whole deal. Okay, all the work that we're going to do basically is to find this point right here. Well, we already know one point, don't we? We know this green point. Now, I wrote a negative 7 here, but what's the actual ordered pair of this point? 0, negative 7, okay? And so we're trying to find, eventually, we're trying to find the distance of that little red line. But what are our steps? Our steps are to find the equation of both lines, correct? Or not both, well, yeah, of the green one and, I'm sorry, I lied. The equation, I'm trying to find this point right here, okay? So I'm trying to find the equation of what? The red one and the orange one. Why? Because those are the two lines that form that point right there. You follow me? So I already know one of them. What one do I know already? The orange one, okay? So let's write down the equation of the orange one, which is y equals x minus 11. Now let's find the equation of the red one. Now that shouldn't be all that difficult to find the equation because I already know one of the points. In fact, I know the y-intercept, don't I, of that red one. So I can write that down. Because look, it hits right here, doesn't it? Isn't that the y-axis? That's where that red line hits that y-axis. So b equals -7. And I know the slope of it, right? Because the slope of the orange one was it was +1. So the slope of this is going to be the negative reciprocal since it's perpendicular. So the slope of the red one is going to be -1. Make sense? All right, so now I can easily find the equation of the red one. So y equals what? -1x, or you could just say what? Negative x minus 7. All right, so here's one line that I wanted to find, and here's another line that I wanted to find. And what am I going to do with those two lines? I'm going to set them equal to each other. So let's go blue on this one. And I'll scooch it down. We'll come back up to it when we're ready. So let's set them equal. So we're going to set this one equal to this one. All right, that equal to that. I always like the positive one to be on the left-hand side. Just makes things a little bit easier, I think. Minus, whoops, big old minus, -7. Okay, then we solve for x. Add an x gives you 2x. Add an 11, what's that give you? 4. So x is 2. You with me? Pretty simple, right? No fractions. That was nice, wasn't it? All right, so now we got to find y. I could use either this one or this one. Let's use this one right here since it's positive x. So y equals x minus 11, or 2 minus 11. So what is y? It's -9. What did we just find? Why did we care about solving for x and y?
Because that's the point.
That's this point right here, okay? Does it kind of make sense that it is 2 -9? That doesn't look like a 9. Make it look like a 9. Yeah, because look, over 2, down -9. Yeah, it definitely looks like where it should be. And always do that. That's why it's good to have a fairly accurate picture. It doesn't have to be perfectly accurate, but it's got to be fairly accurate because, you know, if it said like -23, +457, you knew it would be way off, right? So it's 2 -9. Even if it said 2 +9, you'd know you'd be off, right? Because it has to be in this quadrant right here. All right, so that's our point. That's this x and y right here, and we can just put that in there, which is 2 -9. And now we can find the distance. Remember, the whole idea is to find the distance of that red line right there. Make sense? All right, now I got the 2 points, and now I can solve. So it's 0, -7, and it's 2, -9. Now I can find the distance between them. You have to know the distance formula, which I'm sure you guys dream about every night, right? So subtract the x's, so it's 0 minus 2, subtract the y's, and it's -7 minus a -9, which is +9. That's -2 squared, which is 4. This is a 2 squared, which is 4, square root of 8. If you want to keep it square root of 8, you can do that. It's perfectly fine just to keep it the square root of 8. And that I would. If I was you, I would just keep it the square root of 8. That's it. That's pretty easy, isn't it?
Yeah.
Especially when there's no fractions, all right? Let's do the other one, from a point to a line. Sometimes this is a little bit more involved. 20 or 21, you said 21. Okay, so line L contains these 2 points, 6, 5 and 2, 3. And point P has a coordinate of 2, 6. All right, so let's figure out what's going on here. We're trying to find the distance between that point P and that line L. So we're going to do a little rough sketch of this. So this is 6, 5. Let's do this in another color. Let's go yellow this time. 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, so it doesn't look exactly perfect, but it's good enough. That's 6, 5 right there. And then 2, 3 would be about right here. 2, 3. All right, that's line L, isn't it? That doesn't have to start and stop. No, it's a line, so it keeps on going through. So that's what we're going to do. Make it keep going through like that. Oopsie daisy, sorry. There we go. All right, so there's our line. And we want to find the distance from this point to 6. So let's make it this a different color. 2, 6. I think 1, 2, 3, 4, 5, 6 would be one more, right? So 2, 6 would be about right there. We want to find the distance from that point to this line. So we draw a line that is what to it? Perpendicular to it. Because that's the definition of the distance between a point and a line. All right, and that point right there is 2, 6. All right, well, it's very similar to what we did on the other one, isn't it? Remember, they intersect right here? So we are trying to find this point, xy. That's what we're aiming at. So first thing we do is to find the equation of both of those lines. Let's find the equation of the yellow one first. So we can do that because look, the yellow one is line L, and so I've got 2 points. I should be able to find the equation of the line if I know 2 points. Let's find the slope first of the yellow line. So the slope is the change in y over the change in x. 5 minus 3 over 6 minus 2. All right, and that's 2 over 4, which is 1/2. So the slope of the yellow one is 1/2. Now we have to find the y-intercept. So we put it in y equals mx plus b form. Or you could use point slope form if you wanted to. Seems like I always end up using this one. So we could use either one of these points. Let's use the smaller one. Let's use this 2, 3. It doesn't make any difference. So 3 equals m, which is 1/2, times x, which is 2. That's times, and then plus b. Now, it works out nice and easy. No fractions or anything, right? Because look, that's what? Doesn't just cancel out. What does it become? What's half of 2? It's a 1, right? And then you subtract a 1. What is b? It is 2. And that's pretty close, isn't it? For my little rough sketch right there, yeah. It looks like it hits right there at 2. So what's the equation of the yellow line then? Y equals 1/2 x plus 2. We'll put that in a box, hang on to it. Now let's do the blue one. Now since we know something about the yellow one, the slope, we can find that on the blue one, can't we? So what's the slope of the blue one? It's -2 because it's the negative reciprocal of 1/2. So it's -2. And what is the y-intercept? Well, we do the y equals mx plus b thing. All right, and so what point are we going to pick? We can only pick one point, this 2, 6, because that's the only point that I know lies on that blue line, correct? You can't choose from either one of those 2 yellow ones. You can only choose 2, 6. So 6 equals m, which is -2, times x, which is +2, plus b. 6 equals -4 plus b. Add a 4 to both sides. What is b? It's 10. Does it look like it would possibly hit 10? Sure, because if it keeps on going, this is 6, right? Right here is 6. If it keeps on going, sure, that looks like it could be 10. So it looks like things are working out pretty good for us. So y equals -2x plus 10. Put that in a box. Now, what do we do with those 2 things? Just like we did on the other problem. What is that? Come on, talk to me. Set them equal to each other, right? Set this equal to this. All right, that thing equal to that thing. Again, I'm going to put the positive on the left-hand side, so 1/2 x plus 2 equals -2x plus 10. Get the x's on the same side, so we add a 2x. Tell you what, instead of writing 2x, let's write it 4 over 2x. Why did I do that? Yeah, common denominator, fractions, right? Everybody with me on that? So that got rid of that. Let's subtract a 2 from both sides, and let's see what we get. What's 1/2 plus 4/2? It's 5/2 x. Just think it's easier to work with fractions. I really do, okay? Hopefully I'm convincing you. I don't know if I am or not. How do you get rid of this? Times by the reciprocal, right? 2/5. And we get x equals, what's that? 16/5. All right, not that pretty, but it'd be nice if we got all whole numbers, but we don't, but we can work with it. Don't fret, all right? What do you want to, where do you want to put that? Do you want to put it in the 1/2 x plus 2, or do you want to put it in? All right, let's put it into that then. So there's our x. So let's put it into this one right here. So it's 1/2 times x, which is 16 over 5, and then plus 2. Well, nothing cancels. Oh, yeah, it does, doesn't it? The 2 goes once, and the 16 goes what? 8 times. So that's 8/5 plus 2. But let's rewrite 2. So it has a denominator of 5. So 10 over 5 is 2, isn't it? See how easy it is now after you get a little practice on this common denominator stuff? Yeah, you just need to get used to it again. The common denominator is 5, and this is what? 18. So there's my point, 16 fifths and 18 fifths. And let's write it in there. And let's keep it as fractions, because I want to show you how they got that answer as a fraction, okay? What was it, 16 fifths and 18 fifths? Okay, and now what do we want to try to do to this little blue thing right here? Find the distance, right? All right, and tell you what, let's drop down here where I have a little room. And what was it? It was 2, 6 was the one, right? And then we're finding the distance between that and this. Now, if you wanted to, you could make these a decimal and put it in the calculator and put it in the, you know, that kind of thing. I'm just doing this just to show you how they get that crazy answer that I read off, okay, in the book. You follow me? If you wanted to, again, you could put this into a calculator, get a decimal, and then it's fine. I wouldn't mind that. But I just want to show you how they get that number. So let's do the distance formula. And this is good practice with fractions. Again, I think you always need practice with that. So you subtract the x's from each other, correct? So it's going to be 2 minus 16 fifths. And then you subtract the y's, it's going to be 6 minus 18 fifths. All right? Well, let's rewrite 2 with a denominator of 5. We've done that once already. So it's going to be 10 over 5. 10 over 5 minus 16 over 5 is negative 6 over 5, correct? And we're going to square it. What about this? Instead of writing 6, what over 5? Is that us already? Yeah. So that's 30, and that's what? 12 over 5, and then you square that. Okay? No, I'm going to let you hang on to that homework to study for the test, but I'm going to collect it tomorrow, though, okay? Did you pass the study guide in already? I think you did. I might have it to you. Okay. Let me see if I have any homework to give back to you before you go. You can finish that up. It's fine. Does that help a little bit, though? All right.